Hello friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. This channel provides basics of finite element analysis and computer-aided mechanical engineering design and analysis using CAD-related software. Let's get started.
Hello friends, today we'll show mechanism analysis of Geneva wheel. This will be done using PTC Creo Parametric, right? In this mechanism, it is consisting of three components. One is Geneva wheel, another is disc driver, and another part is base plate, right? So on the base plate, both of these will be connected through pin joint. Okay, let's get started. As the models have already been made, so we'll start from assembly itself, right? Let's take assembly, and default template should be unchecked. Okay, and from this template you should select millimeter newtons second assembly design. Okay, we'll select different parts from this assembled part. The model is already saved in the desktop by the name of PTC. So from there we'll select different parameters. First of all, we have to select the base plate that will be fixed at the bottom surface, right? We'll select that part number 8. This is base plate. While locating this one, it should be provided at the default position. So status is fully constrained, green check. The base plate is fixed. Next one by one, we have to select different components. First of all, we select that Geneva wheel, that is known as part number 6. Okay, let's take that one. This is the Geneva wheel. Now from this drawing or from this model, it is clearly visible that we should provide pin joint between these different components, right? That pin joint can be connected from user defined pin. Now let's select the surfaces or these parts. Which one should be joined together? This part should be joined with this hole. One constraint is done, another constraint is required. So another will be, let's consider the surfaces. This surface should be meeting the bottom surface of this one. Okay, done. This is perfect. Now second one, right? Second one should be inserted. Now before that one, what can we do is we can rotate a little bit this one, in which while inserting the second one there should not be any problem, right? So we can drag it. So what we'll do is, before we can see the different views, we can see the top view. This is top view. Now this one we can align a little bit better way by dragging. It will be like that. Okay, you can select these all surfaces. Now if it is required, we can drag it more or less, right? Let's see it is perfect or not. Let's drag it again. Perfect. Close it. Okay, next we have to insert that driver part. So we are selecting assemble part number 7, that is the driver wheel. This is there, right? Again, by using the same method, that is pin joint, this should be connected at this hole. So select from user defined pin. We have to select the bottom face of this cylinder and this hole. Okay, now another constraint is required. That means you can see different surfaces. Back surface of this wheel should be meeting top surface of the base plate. Okay, done. Okay, complete. Now one thing is required, that means we have to consider the mating surfaces, 3D mating surfaces, right? That can be done from analysis, applications, mechanism. Here we can see 3D contact surfaces, right? 3D contacts. We have to see the reference, that means object, reference object is required. This is the reference object. Next we have to select the different surfaces, that means slotted areas, right? We're having 8 slotted areas that will be selected one by one. Okay, let's select those surfaces. By control we can select All the surfaces have been selected, so green check. Our model is ready for analysis. Okay, now these different planes and this axis looks odd, so we'll make it off, right? Okay, another thing can be done. This colors looks very dull, so we can change the color bit a little bit. The appearance of this model can be a little bit changed, so we can do it from view, appearance. We can select different appearance. Let's select this one for the driver disc. Driver disc part selected. This appearance done. Now for the Geneva wheel, let's select different appearance. Let's select this part. Okay, done. Now for the base plate, let's select something else. For the base plate, let's select this part. Okay, done. Okay, it's ready for analysis. Now for analysis, we have to start with applications, mechanism, right? Okay. And we have to provide a motor at this location also, right? So select mechanism, servo motor, that to be applied here, right? Location is a reference is required. Reference is this location, and this profile details, we have to select angular velocity. Unit is degrees per second, and let's provide the angular velocity equal to 30 degrees per second. Done. Now we have to run this mechanism. For running this mechanism, we start mechanism analysis. It is analysis definition 1, and we are selecting kinematic analysis, right? Here starting time is 0 and end time, let's take the end time equal to 50 seconds. Then run this part. It is running very nicely. You can see it is run for 50 seconds, right? Okay, now we can do this one thing, like we can make a video of this one by using different formats, right? For making this video or film, we start from playback. We'll keep this one this side. Now from playback, let's select this part, and we can increase the frame rate and velocity also, right? Frame rate we are increasing a little bit, and velocity or speed also increasing. Let's drag it to the left side and make it a little bit more. Then run this one. It is showing that the mechanism is running very smoothly, right? It is looking very nice. What can you do is, we can make a movie of this one. For that we have to capture, right? Let's stop this motion and let's capture this one. While capturing, also different formats are available, as I already told. It is being saved by the name of ASM004 MPG. We can change the format. Different formats are available. MPEG format is also there, and AVI is also there. Better select MPEG format, right? Okay. Now it is selecting the standard size is 640 by 350. We can change it to the level of HD format like 1920 1080p. Also we can change it, right? And frame rate is 25. We can change it to 30 frames per second. 30 frames per second. Okay. Okay. It started taking the video. Okay, it is complete. The movie is already generated. Now we can do one thing, like we can go for analysis part, right? Close this part. Now for analysis, what can we check it? We can check velocity, acceleration of different places, right? The base, this base plate is already fixed, and this driver disc is already moving with a input velocity what is given already. So no need of finding the input velocity of this one, as we know. We can find the velocity and acceleration of different parts or different places of this Geneva wheel, right? We'll show that one. How to check this analysis? We'll start from measures. Starting from measures here itself. Now the thing is, we have to select, already we have done this analysis definition 1, that to be selected. Now we can go for different types of analysis, right? We select here. It is asking the name as measure 1. We can change the name as velocity or something else. Velocity, and position will be replaced by velocity. Select the location at which place we want to have velocity. That's position. Okay. It is showing velocity of that position equal to minus 11.811 degrees per second. Okay. Now again we have to see the acceleration of that location, right? We'll select measure, we can change the acceleration, and position will be replaced by acceleration. Now let's select that location, the same location we want to find out. Okay, it is showing acceleration equal to minus 20.766 degrees per second square. Okay, now we want to see those graphs, right? We want to select the velocity graph, velocity versus time. We have run this one for a certain time. Within that time range, you can see the velocity of that location. So for graph, we can select here itself. It is showing the graph. That means it has started from 0. It has come down to certain level, minus 76 something else. After that, it has gone up again. Then again, velocity was 0. So this is the graph against velocity versus time of that location, right? We can save this part, or you can export it to Excel, and that will provide a lot of data, and that data we can analyze later on. Okay, we can export it to Excel also, right? Close it. Next part, we will see the acceleration graph. Acceleration, then select graph. It is showing the similar type of behavior also. Main acceleration is 0. It is coming down to minus 35 something else, and again is going up to 20 degrees per second square, maximum one, right? Again, like the previous one, we can export this data to Excel, and for analysis we can have lot of data from this Excel sheet. Okay, done. Next one, we can do one thing. We can plot both these graphs together, and also separately also we can do it. For plotting these two graphs separately together, what can you do is you have to select both these components together. We have selected, then graphs. It is showing both the graphs together, right? Again, if you want to plot separately, graphs measure separately. Here itself it will be clicked. So this is all about mechanism analysis of a Geneva wheel, right? We can do some other thing also, like curve tracing, but here in this case curve tracing will not be having any kind of meaning, but because we know how the different parts are moving. This is already having one circular motion. This is also little bit of circular motion. That means here continuous circular motion is converted to intermittent motion, right? So here no need of actually meaningless to find out the curve tracing. We can do that one also. So in this analysis, if you find it is useful for you, please like and subscribe. And if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.